Here we go. All right, everybody focus? All right. Do you notice that this is made of two elements? So it's binary, right? Is that the word? Binary? Is it a metal and a non-metal? Look on the periodic table if you forgot. Is it a metal, non-metal? Is it an always metal? Okay, therefore, you don't use Roman numerals, do you? That's kind of easy. So what are you going to call this thing? And all binary compounds, the name ends in what? I-D-E. So what are you going to call this? Magnesium fluoride. What do you think about that? Can we move on? I don't think you should have missed the first one. Number two, is this is not binary, is it? If it's not binary, I have some good news. It contains one of these things called, what's this called? Hey, I hate to bother you. Can you close that door also? Polyatomic ion. It's a bunch of atoms bonded together, act like an ion, and so we go look for it. And if you go look for that, it's got the word nitrate, and you never change the word, the name of a polyatomic ion. So now, I would have put iron nitrate. But why did I have to go back and do some extra work? What was it about this metal that made me say, nope, you got to go back and do a little extra work? I'm looking at everybody's their face, okay? You got to look at me right in the eye. What do you think? This wasn't always metal. Is this one? No. If it's not an always metal, it means they can do. There's more than one iron nitrate. So now, here's the hard part. What's the charge on nitrate? And there it is. It's right down here. It says nitrate has a charge of -1. All of these are -1, aren't they? So now, if nitrate's -1, that whole thing, see my hand? That whole thing's -1, all right? But how many nitrates do you have? What's that little 3 mean? 3 of whatever's inside there, right? If each nitrate's a -1, you have 3. What's that give you? Isn't that -3? And all compounds have a net charge of what? Okay, so what's -3, and what does this have to be to make 0? Okay, and Sean, I hope you don't mind me saying your name again, but you're the expert. You didn't miss any of these, did you? What Roman numeral did you put on yours? Good. You should have not missed it, because he knows that the Roman numeral is the charge on the what? On the metal. What do you think? Now, some of you put iron 2. Think about what made you put a 2 instead of a 3. And see if you can fix that. How about the next one? What do you think? Is it binary? Is it a metal or non-metal? Is it an always metal? Well, then I don't even have to do any extra work, do I? What are you going to call it? Potassium oxide. All right. Are you learning your elements? Yeah. Okay, go 1 through 20 for sure, and then you'll see the other ones you can do, okay? All right, how about this guy? Is this a binary compound? One element, sodium. Here's another element, oxygen. Here's another one, what? Oh, it's not binary. That means it has one of these what in it? What's it have in it?
Polyatomic ion.
And this polyatomic ion is called hydroxide. There you are. Got that? But why do I not have to do any extra work? Why do I not have to worry about the charge on the metal here? Why not?
Because they don't have any net charges.
It's a what?
Net charges.
What do you know about sodium? It's always +1, isn't it? I don't have to do any extra work. I just say the name. No Roman numeral. Sodium hydroxide. All right, next one. Is this binary? Is it a metal or non-metal? And is it always metal? Oh, okay, what are you going to call it? Sodium phosphide. And then the next one is a little bit harder. This is a little bit harder. This is not binary, is it? So what is this right here? We got to go look for that guy, don't we? Here he is. What's his name? Phosphate. Now, what's the charge on phosphate? -3. Now, watch now. How many phosphates do you have? Each phosphate's -3, but how many phosphates do you have? 2. What's 2 times -3? -6. Well, this better be +6 over here, so 3 times what equals +6? Aiden, what do you think? 3 times what equals plus 6?
Oh, 2.
And the charge in the metal becomes the Roman numeral, and that was lead 2 and phosphate. You never change the name of phosphate. Now, I would say most of you did pretty well on the left side. Is that right? If you didn't, you can fix that. Don't you think you can fix that? You have till Thursday, don't you? You want to get type 1 and type 2 and type 3. That's the easy part. Let's go over here, and here's where some of you still need work. And remember, the whole quiz is only worth 30 points. I didn't try to beat you up on the quiz, so it's only worth 30 points right now. The test will be big. The test will make a difference for many of you on what you get on the second quarter. Some of you are right between A and a B. Some of you between a B and a C. We want to do well on this next test. You got that? And your homework, you're going to turn your homework in, aren't you? Now look over here. It's a little different animal. Because I know that calcium, look over here, in a compound, calcium's always what charge? And everybody should be looking at the periodic table. What is it? Okay, plus 2. And what about chlorine? Does everybody know how to do those? All right, plus 1, plus 2, silver, zinc, aluminum, plus 1, plus 2, plus 3. And what about the minus guys? All the fluorine group, that's minus 1, oxygen group minus 2, nitrogen group minus 3, right? Okay, so here we go. Calcium's plus 2, and chlorine's minus 1. Now, look out here. That's not going to work. Some of you put CaCl. That's not going to work. Why? All compounds have a net charge of what?
0.
That's not 0. Plus 2 and minus 1, that's not 0. So what do you need more of? How many minuses do you need?
2.
2 of them, right? So I put a little subscript 2, and I think everybody should have gotten that one right. All right, next one, a little harder. This one's harder. Lithium. What charge is lithium up there? Look up there. Look up the periodic table. What's lithium? Plus 1. What about nitrogen? See, this is nitride, isn't it? So it's just nitrogen. That's minus 3, isn't it? What are you going to do if this is plus 1 and he's minus 3? What are you going to do? Now, some of you put a 3 on the nitrogen. I don't need more minuses, do I? I have a lot of minuses, but I do need a total of 3 pluses. So 3 times plus 1 is plus 3, isn't it? Plus 3 and minus 3, and that's how we do it. Next one, a little difficult. Ferrous. Okay, now you don't have to memorize this because I'm going to put it on the periodic table, all right? Iron 2, iron 3. What's another name for iron 2 or iron 3? Who's the big, icky monster? So he'd be ferric, wouldn't he? So plus 3 is ferric. What's this guy? Ferrous. Okay, so here we go. Ferrous means what? Not plus 3, but plus 2. So I'm going to put a little plus 2 there. And what about sulfur? Look at sulfur. What do you think? Taylor and Colony, right? What's sulfur in a compound? What's the charge of sulfur in a compound? Yes. So if this is plus 2 and this is minus 2, why did some of you write all kinds of subscripts down here? Did they already add up to 0? Then it's a compound. You don't have to go any further, did you? Next one, gold 3. All right, gold 3. See that 3? That's what I told you, gold 3. And what's the charge, Luke, what's the charge of oxygen in a compound? Look at the periodic table.
-2.
It's right. So gold's plus 3, oxygen's minus 2. What are you going to do about that? How do you fix something like that? Plus 3 and minus 2. How do we do it? Every time we did it in class, how do we do it? So the lowest number they both go into is 6, right? And so 2 times 3 is plus 6. 3 times negative 2 is minus 6. So you put a 2 here and a 3 here. That was probably the trickiest one on there. Let's go to the next one. Now, I agree, you're not experts at this at all. We're just starting out, aren't we? But there is no element called ammonium. So where are you going to look to find ammonium? And you know what? The only polyatomic ion that will ever be written first, because he has a positive charge, isn't he? Is ammonium. So what I did is I wrote ammonium and a plus 1 charge. That's what it says. And then what about acetate? That's weird. Some of you giggle when you say it. Acetate. Okay. But anyway, here's acetate, right? And it has a minus 1 charge. So This guy's +1, and this guy's -1. What do you think? Am I done? I'm done. +1, -1. Next one, copper 1. Copper 1. So put copper +1. Sulfate. Go down here. Oh, you're SO4, and you have a -2 charge. So what are you going to do? I have a +1 charge. You have -2. How are you going to fix that? What do you think, Matthew? How do you fix that? Copper's +1 and sulfate's -2. How do I fix that? Yeah, 2 times +1 is +2, isn't it? What's +2 and -2? That's what we want. Next one was a nice one, a little softball question. I like softball, but softball question. Potassium's what in a compound? +1, and what about iodine? What do you think? +1, -1? I think we're done. All right, let's do another one. All compounds that have a net charge of what? Give me about 3 more minutes. 3, sorry. All compounds have a net charge of what? 0. All binary compounds end in what? IDE. What's the only time that you use parentheses in a formula? And I don't have one up here. What's the only time you use parentheses in a formula? And if you did the bonus question, you would know. All right, look at the bonus question. Stanic. No. Oh, yeah, there's a big icky guy. He's +4. And what's hydroxide? -1. Uh-oh, I need 4 what? Not H's, I need 4 what? OH's. So when's the only time you use a parentheses in a formula? We need more than 1 polyatomic ion. Now, what I did, to be nice, is I made the bonus 2. If you left out the parentheses, I still gave you 1. And I also subtracted from 32. That means the first one you missed didn't count against you. And that's why some of you got a 32 or a 34. We had somebody get a 34 in this quiz. That's pretty good. That's pretty good, isn't it? All right, now, I would like you to keep this, but Thomas hadn't taken this yet, so if you don't mind, if you could turn them face down and pass them to the end, and then when they come to the end, Ben, you can pick them all up. Yes?
What does that have to do with softball?
Oh, somebody says you threw them, like if they were interviewing the president and this one network gave them these questions like, well, how was your Thanksgiving vacation? How was your Thanksgiving dinner? You know, instead of asking them a question that was really a tough question, they call it a softball question, meaning it's an easier game. Now, I actually played softball. After I got out of high school, I played softball for 26 years. So I actually like softball. I played on traveling teams, and I love softball. So, but unfortunately, when it first started, softball was a game you played at picnics, and baseball was one you played in a stadium or something like that. So that term, softball question, still sticks around. It means it's easier than the hardball question. I mean, if you could put those over there on that desk somewhere. And all right, what do you think about the quiz? How many people felt pretty good about the quiz? If you got an A or a B, even a high C on that, I think you're in good shape so far. So far, we're not done yet, are we? We're not done. All right, tell Thomas he can come in now. Now, what I want you to do is, if you feel like you're in pretty good shape, all you have to do is we're going to finish. We're going to finish everything today. Now, before we finish, I'm going to tell you what's going to happen here. Does everybody have their packet? Go ahead and get this out. And let's get this other one out, too. Let's get both packets out. So everybody get both packets out right here. I want to give you an assignment, and you're going to want to do this assignment, okay? The other class, what I did, they had to memorize about 28 of these polyatomic ions, okay? You want to do that?
No.
I don't think so. So what I'm going to do is, I'm going to make a deal with you. Is that for this test, you won't have to memorize any of them if you bring this to the table. So what I'm going to do is, your assignment is you're going to make polyatomic ion flashcards. Now, they're going to be color coded, and I'll show you how to do that. And these have to be turned in on Wednesday. It will not take you that long to do these. But if I check them over on Wednesday, I will let you use them on the test on Thursday. I will not give you this on Thursday. I will not give you that. You'll use your own cards. Get that? So here's what's going to happen. Color-coded polyatomic ions. They have so many studies that show that when people use color in their notes and things, there's like a 30% increase in how much you remember. Coloring. Have you ever seen somebody who colored their notes? They use color to highlight things. There's an increase in memory by doing that. Now what we're going to do is we're going to take, and let's say, I don't know, Aiden, do you have a favorite color? Blue. Okay, so let's say Aiden's favorite color is blue. Aiden, take a look here. Do you notice that most of the polyatomic ions have a -1 charge? So you're probably going to use blue for that because you like blue. Now, you don't have to go out and get blue index cards. I'm not asking people to go out and buy these. But you have to have some kind of marker at home that's blue. So he might do like this. He might go, he might make just a line like that, and that might be blue. And he might use blue, and he might on one side write NO3, and he has to put a charge there. Why? Because it's a polyatomic ion. What do ions have? It starts with a CH. Ions have a what? A charge. You can't just write NO3. You have to write NO3 with a -1 charge, don't you? Now, what are you going to put on the back side? What are you going to put here? Nitrate. Okay, so for right now, you're not going to have to force you to memorize any of these yet. Now, when you get back from Christmas, I'll play some games. We'll try to memorize maybe about 15 or 20 of these, something like that. We'll have a... All right, so anyway, by Wednesday, I have to have them by Wednesday because I have to check them, and if they're wrong, I have to, have you fix them, and you can't have anything else written on there besides this, okay? So you can't write anything else like test questions, stuff like that. All right, is everybody okay on that? So if you were to make everything blue, that was -1 charge, and then you're going to have another color. You're going to have another color for the -2 guys, right? And by the way, I know I'm not going to have you learn this one. I'm not going to have, well, this will be an extra credit one on the test. I don't use, well, maybe that'll be extra credit also. You don't have to learn those. Well, go ahead and make them anyway. How about that? Go ahead and make them. Let's just do that. Just go ahead and make them. And here's another color, right? The -3s. And how many cards are going to be +1? Just one. And when you get done, you'll say, wow, you know what? There's only one of them that's +1. There's only 2 of them that are what? -3. And there's only a few of them that are -2, and the rest of them are -1. All right, so one more time. These are due Wednesday. And again, you don't have to go out and buy colored index cards. I've seen people just take paper and they cut it into rectangles and they made the flashcards. They're not for me anyway. Who are they for? They're for you. So make flashcards that you eventually will use to memorize some of these. You get it? But I'm going to let you use them on the test. I just won't give you these. I won't give you a periodic table with these on there. Got that? But if you have your cards, you'll be able to do it. Please make sure you have your cards. That test would be really hard without those cards, wouldn't it? All right, what I'm going to do now is we're going to go to the last 2 things. And here it is, type 4. Now, type 4 is naming, and I have another deal for you on Wednesday. If you're here on Wednesday, I have another deal for you. Might have to do with another index card. So make sure you listen all week. All right, first of all, what they decided was there's this group of chemicals that were really important, and they were called acids. And they want to name them differently. They want to name the acids differently. And so how do you know if something's an acid? Well, the compound starts with an H. Now, if you look on my handout sheet, you'll see that it says here, in acids, the star of the show is hydrogen, and the compound's going to start with H. And the only exceptions I know of, and I understand nobody likes exceptions, but water is not considered an acid, even though it starts with H. And this stuff here that some of you put on cuts called hydrogen peroxide, those are the only two that I know of that start with H that are not acids. So, anyway, what you're going to do then is to name acids, you're going to first of all recognize that they're acids. See how it starts with H, starts with H? Okay, not bad. Now, this is where you have to pay attention. The most famous acid that I know of, that your stomach makes this acid. Your stomach makes this acid all the time. Did you ever have a teacher use this in her science class? Have you had this? Have you heard this word before? Have you ever seen that? Hydrochloric acid. Have you ever heard of this before? Okay, so I want you to memorize this guy. What's the name of this right here? What's the name of that acid? Okay, now that's my model. It's going to be a model for every acid that has no oxygen in it. Now, this is how they name acids. They said, hey, you're an acid that has oxygen or you don't have oxygen. This guy does not have oxygen, right? No oxygen. So what's my model? If you're an acid, see how it's an acid? And you have no oxygen, you will start with hydro, you will end in ic. Can you remember that? Now watch. If you're an acid, look at these right here. Are these acids? They all start with H, don't they? Now I have to name them like an acid. Now, they don't have oxygen, do they? So I'm going to name them kind of like this guy. You'll start with hydro. You'll take this and make that the middle, hydrochloric acid. So what would you call HBr? See, it's an acid, no oxygen. I'm going to follow the model. What are you going to say? Hydro, brome, ic, acid. How about the next one? Here's an acid, no oxygen. My model is HCl. What are you going to call it? Hydro, iodic acid. Next one. Here's an acid, no oxygen. Use my model. What are you going to call this one? Hydro, sulfuric acid. Isn't that sulfur? Look at the last one. Hydro, help me out. Fluoric acid. I don't know if you're any of you watched the series called Breaking Bad. Did you ever watch that series? Okay, it's about a high school chemistry teacher, and his wife has a serious illness, and they don't have very much money. And if you watch the whole series, he gets himself in a situation where it changes him. But he's a chemist anyway. He somehow, I don't want to give away the whole thing, but there's this one person that they end up dying. He ends up dying, and they have to get rid of the body. And did you remember what he did? Do you remember that episode? And he said, go put him supposed to put him in a plastic container, because this is a very powerful acid. He said, go put the hydrofluoric acid on it, and it was going to dissolve the entire body. But where did he put it? Instead of putting it in a plastic container, he put it in a bathtub, which was made of metal. It's metal coated with porcelain. And it ate through the porcelain, ate through the metal, ate through the floor, and what happened? Anyway, hydrofluoric acid is a very powerful acid. But can everybody understand that? Why are these acids one more time? How do I know it's an acid? It starts with what? H. As a matter of fact, when you put these in water, the hydrogen ion comes off of them, and that's what makes it an acid. The hydrogen ion makes it an acid. That's why it's written first. H is written first because hydrogen is the star of the acid world. Okay, now if that was the only way you had to do acids, that would be so easy, wouldn't it? Okay, now, let's go to the next page. Now, here, we have these acids that are called oxyacids because they're acids that do have oxygen. And here's what I'd like you to do. I would like you to think about two models. So the model of an acid with no oxygen was this one, right? And now, if you give me any acid like that, I'll be able to name any acid you want that has no oxygen. Hydro, blah, blah, ic acid. Get it? But now, what about the acids that do have oxygen? Now we have to do something. Everybody with me? Do you notice that this saying has oxygen in it and it's an acid? Do you recognize that? Now, here's what you do. All you need to know is what's the name of that polyatomic ion. Now, you don't have these memorized yet, so find your sheet. What's the name of NO3 nitrate? Okay, now. Nitrate. Okay, now notice it ended in 8, didn't it? If the polyatomic ion ends in 8, then the acid is just ic. Now, we don't say hydro. Hydro is reserved for acids with no oxygen. Get that? Don't say hydro. Just say nitric acid. What do you think? Now, what about this guy? What's his name? What's this polyatomic ion's name? Nitrite. Now, if it ends in ite, it becomes us. And some of you are going to like this little memory trick here in just a minute. Look right here. NO3, NO2. Who's the big, icky polyatomic ion? Nitrate. Look now. I can use that memory trick again, can't I? NO3 has 3 oxygens. NO2 has only 2. The big, icky nitrate becomes what acid? Say it. What is it? Mallory, what is it? Nitric acid. And the one that's not the big icky, he's a nitrite, he becomes nitrous acid. That's it. That's everything you need to know about naming acids. If you knew these 3 models, you'll know every acid. Now I'm going to give you some, and it'll say you'll be surprised that you can name it. You're going to be surprised that you can name it, all right? Let's do this one. H2SO4, H2SO3. Now, is this an acid? Is this an acid? How do you know? It starts with hydrogen. Does this acid have oxygen in it? What's that right there? I know, but isn't that made of sulfur and oxygen? Does it have oxygen in it? Yes. What's the name of the polyatomic ion? What is it? You don't have these memorized yet, so you might as well look. What's the name of the polyatomic ion? Sulfate. Sulfate. So what's the name of the acid? Sulfur what? Ic. And what about this guy? He's not the big icky sulfate. He's sulfite, isn't he? So what kind of acid is he going to be? He's not ic, but he's us. Remember ic and us? Everybody remember ic and us? Okay. All right, what do you think? All right, so now let's go to your homework sheet. Let's go to your homework sheet. And did everybody know that I made a mistake printing these and about 2 or 3 pages are repeat pages? Would you please tell me when you turn this in on Thursday, would you please show me that you don't do the same page twice? Would you? Now, if you said practice, you said, I wanted to practice. But 3 of these sheets are repeats, so please don't do it twice. You get it? All right, so watch right here. Here, I'm going to show you how to solidify the lesson today. Are these all acids? Are these all acids? Well, number 1, it says naming acids, and they all start with H, so I think it is, isn't it? But which one do you want to do first? I'm going to try to train my brain here, so which one do you want to do first? What kind of acid do you want to do first? What do you think is the simplest kind? How about the ones that have no oxygen? Let's find an acid that has no oxygen in it. We're going to do number 2. We're going to do number 6. We're going to do number 9. All right, ready? What's the model? What is the model for acids with no oxygen? Isn't he the model? What's his name? Yeah, with no oxygen, you say hydro, and you have to in and ick, don't you? So what is this one? What's the middle part of this going to be? Yes? Hydrochloric acid. Now go down here. No oxygen. What are you going to start with? Hydro. I'm going to use my model, aren't I? Use your model. Hydro what? Bromic. Has in and ick, doesn't it? Acid. How about this guy? I have no oxygen. No oxygen in there. What are you going to start with? Hydro. Ooh. And they could have said sulfic, couldn't they? But they decided to call it what? Sulfuric. What do you think? Okay, you're doing a great job so far. Stay with me, okay? Remember on the quiz, some of you were really good at naming, and what happened when I gave you the name? Something didn't work, did it? Let's go over here. Let's go down here. Find the acids who have hydro in them. Which one? 13, 15, 20. Are you ready? All right, follow along with me right here. Hydro means there's no oxygen in there. I know you have H because you're an acid. There's no doubt you're going to start with H. Hydrochloric acid. What's the other element? There's no oxygen in it. So what's the other element? Now, don't be smart, okay? What's the charge of hydrogen in a compound? If you look where he's at, it's +1. But what's the charge of chlorine in a compound? -1. So guess what? We're done. Next. Hydro. What's the other element? Fluorine. Hydrogen's +1. What's fluorine? Are you sure? Is everybody sure? -1 or not? I think we're done. Next one. Hydrosulfuric. What's the other element? All right, hydrogen's +1. What's sulfur? Oh, -2. Hey, you're trying to trick me now. How do I fix that, Aiden?
Like, put 2 next to hydrogen.
Yes, subscript 2, right? Very, very good. All right, we're almost done. Let's go back up here now. Let's do the acids that do have oxygen, but the polyatomic has to end in 8. Look on your chart. Do you know what NO3 is called? What's NO3 called? Look on your chart. Nitrate. All right, let's go down here. What's SO4? Sulfate. SO3, no. That's sulfite. What's this guy? Look at that weird guy. Acetate. And what about this guy? Oh, that's nitrite. No. How about this guy? PO4. Phosphate. And what about this guy? What's CO3? Look that one up. Carbon 8. Carbonate, isn't that right? Let's just do the ones that have oxygen in an 8. What's my model? See this? If you're a big icky 8, if you're the big icky nitrate, then you get to become one acid. And don't say hydro. Hydro's for acid with no oxygen. So what are we going to put here? What's the main element right there? Nitrogen. So you say what? Nitric acid. What are you going to call this one? It's going to end in ick. What is it? Sulfuric. Oh, I said ick twice. Sulfuric. What about this one? This one's found in vinegar. What's this name again? You don't have them memorized, so look them up. Acetate. Acetate. So what's the name of the acid? Acetic acid. That's what vinegar. Vinegar, when you buy vinegar in a store, it'll say it contains 5% acetic acid. You know what 95% of that bottle is? Water. It's really watered down acetic acid. But it makes your tongue tingle. That's why people put it in pickle juice and mustard, taco sauce. All right, one more. What's his name? What's the name here? Phosphate. Phosphoric acid. And what's this the last one right here? Last one. What's the name? Look it up. I'll give you a clue. It has carbon in it. Carbonate. So what's the acid? No. Why do you not use hydro here? Because it has oxygen. Okay, what do you think? Not bad? All right, thank you very much. We have plenty of time. You get this? Plenty of time.